In today's video, we're talking about something that data vendors like Bloomberg and S&P don't want us to talk about because they charge you millions and millions of dollars for that data. We're building a web scraper that allows you to download index holdings for the S&P 500 and the Russell 1000 on a daily basis. Why do we care about that? In general, what I just described is a very manual process. You go to the S&P website, you download the holdings from there, store them somewhere on your local machine, and probably never look at them again. Also, the data is very messy. As I mentioned, you download an Excel file, probably there's some formatting issues with the date, there's missing fields, there's duplicated data that you just don't want to deal with. And lastly, as I mentioned before, those data vendors are very, very expensive. Also, if you want to sign up for some APIs, you might not want to share all the data. So we're doing all of that for you. We're building an automated system that goes onto those websites, downloads the Excel file, cleans it, and stores it for you. So what are we going to build here? First of all, we built a scraper using Python's package Selenium that goes to the website and downloads the file. In a second step, we clean the file, we validate everything, standardize it, and store it in a SQL database so that you can use that data in your backtesting projects or wherever you want to use it later on. So let's get started. Let's start by importing some of the standard Python libraries such as pandas and numpy, as well as some time calculations such as time and datetime. Before we actually start looking into the Python code for our web scraper, let's go over to the website we're trying to scrape first. We're going to use the iShares S&P 500 website. That gives you like the performance and the holdings and key facts of this fund. If you're going to click on the holdings link here, it's going to get us to the top 10 holdings as of today for the S&P 500. We can see with a weight of 7.8%, Nvidia is the biggest position in the S&P 500, followed by Apple and Microsoft. Down here you can see that there's 51 total pages to it. So if I click on the 2, it will get me the holdings 11 to 20, leading by JP Morgan Chase. You can now imagine that it is very tedious to go in, copy this over, go to an Excel, paste it there, and do that 51 times. Instead, we're gonna have Python help us do it. First, you can see on top here that there's a data download link. If I click that link, it will open or it will download an Excel file for me. And if I open that one up, you can see that there's a holdings tab. In that holdings tab, the first row is once again Nvidia with 7.85%. So that matches what we saw on the website. A little bit easier than clicking through those 51 pages. We can just manually download an Excel file. But instead of us manually doing it, we have Python do the same steps that I just did. Open this website, click the link on the top, and store it on our local machine. There's a similar page for the Russell 1000. So if you want to follow along doing it for the Russell 1000, feel free to do so. It has the same data download link on top, so it will work in a similar fashion. But for now, let me copy over this link and we go back to Python. The Python package that we actually will use to do our web scraping is called Selenium. Selenium is a very convenient package that is specialized on web scraping and web driving. First, let us set the download folder, so the folder where we actually want to store the data or the Excel file that we download. I don't want to put it into my default download folder. I'm going to specify a data folder for it. So if I run that. Next, we're going to import all the packages and sub-packages that we need from Selenium. And we're going to store the URL that we just copied over from our iShares website. That is already all the prerequisites. So let's start by actually going to our driver, or actually building our web scraper. I'm going to copy over some of the options. One of the options here, for example, is that we want to use our download folder that we specified on top. And if you didn't specify it on top, feel free to just comment out those lines. And now we can already start building our driver. Our driver, we're going to use the web driver from Selenium, and we're going to use the Chrome web driver here. We pass in the options that we specified on top. And if I run this one line of code, you can already see that will open up an empty browser for us. Obviously, we don't want an empty browser. We want to pass in the URL that we specified on top. So let's do that by doing driver.get, and we say URL equals URL. So if I run those two lines now, it will open up the same Chrome window again, but this time displaying the iShares S&P 500 website that we looked up earlier. So if I close that. So what's the next step? We already are able to open the website. The next step is we should be able to click that link in the right-hand corner and download the file. Just for our convenience later on, let's already put our driver.quit in there. This is basically just closing the driver after we are done. To click the link in the right hand corner, let me show you a little trick on how to do that. So we go back to the website and we right click into the data download link and we do inspect. This now opens up a window with all the HTML that is rendered for this website in the background. Don't worry if you've never seen this before, it's just like a little background for you here. We can now see the link. Let me scroll over for you guys to see the link. The link is in class icon XLS export. And it also has an ARIA label of download data file. Make sure to keep that at the back of your mind here. So let me go back to the Python code, and we're gonna make use of those two strings that I just read to you here. So we're gonna create our own download links. What's the download link? So we wanna, first of all, wait until the website is fully loaded. So we're gonna do that by saying we're passing in our driver, and we say our time out is like 15 seconds. This is just making sure that we can click the link and it's only starting to execute our code whenever the website is fully loaded. But what do we want to wait for? We want to wait until our link is clickable. So we say ec.element to be clickable, element to be clickable, and now we just have to say which one do we want to be clickable. It should be we're gonna select it by CSS selector, and then the CSS collector is a combination of the two strings that we just looked at. It is the icon XLS export, and we're gonna specify the download data file label that we checked before. And that's already it. So we basically specified our driver, we set our download link and say wait until this element is clickable, and now all we really have to do is just click it. So if we say download link dot click, we can now go in, and we might want to do some, because it's a download, so let's just give it, I don't know, 4 seconds to load or to download our file. But if I run this code, you can now see it will open up the window, it will wait until the window is fully loaded, it will then click the data download file, it will download the file and store it on our machine and close the driver. So we see all of that was done in 14.8 seconds, and on the left hand corner you can now see in my data folder we have a iShares core S&P 500 ETF fund.xls file stored. Now that we have downloaded the file, we are at the step where we want to take that file, format it, and store it into our database. Unfortunately, if we click into it, it is not a standard .xlsx file, so you can't just do pandas.readxl. It is actually stored as an .xls, which if you look into it, it's a XML encoding, which is similar to like the maybe HTML encoding here. So if we close this out, so how do we gonna deal with that XML encoding? We can just use a Python package called BeautifulSoup, which is a very popular and powerful Python library as well. So we start by creating our file path. We just use the same download folder as before, and we're gonna reference the file that we just downloaded. Now we can just reference this and say with open, and we want to open that file path. We open it as XML file, and we now create our soup by using BeautifulSoup, and we say we want it to use that XML file, and we tell it that it is actually XML. And if we run that and we look at soup, we can now see that it has the same XML outlay as before. If we go back to the original sheet, we see that it is stored in like a worksheets format. It has 5 worksheets, and we want the holdings file to be parsed. We also want to pull like all the rows and cell values. And if we go back to the XML outlay, this is exactly what we find here too. We see worksheets, we see rows, we see cells. So in the first step, we want to grab everything that is a worksheet. So we can say worksheets equals, and then we get our soup.findAll. The findAll function is a very, very powerful function that we will use a couple of times here, and we want to grab everything that is a worksheet. So now if you look at worksheets, this now is a list of all the worksheets that BeautifulSoup finds. If we do length of worksheets, we can see it's 5, corresponding to the 5 sheets that our original data frame had, our original data file had. Now we want to grab the holdings sheet. We know that the holdings sheet is the second sheet here. So what we want to do, we want to reference 1 as Python as 0 indexed. We want to grab the second one and say holdings equals worksheets on 1. And if you look at holdings, we can now see our worksheet is holdings and it ends in holdings. So the next step now, what we have to do is we have to iterate over the rows and the cells and grab all the data in those cells. To do that, we first do sheet as list equals a list, and that's the list where we're going to store all the data in, and that later gets transferred into the pandas data frame. So we're going to take our holdings and we iterate over each row. So for row in holdings, and how do we do it? We use that findAll function again, and this time reference the row. So we say for row in holdings.findAll, and we now say sheet as list.append, and we now do the same thing by iterating over that row. We want to grab all the cell values. So we do something like cell.data.text if cell.data else nothing for each cell in row.findAll, and this time we look for cells. So what this is effectively doing is we iterate over each row, we find each cell, iterate over those cells, and grab all the data in there. That gives us a nice list with all the rows, and now all we have to do is store that in a data frame by saying df holdings equals sheet as list equals pd.dataframe sheet as list, and we have our data, df holdings. You can see we finally stored a data frame. Close this out so we have a little bit more room. And yeah, if you go back to this file though, we see that there is a couple of information rows that we don't really need. So we can remove those first 7 rows, and we just do that by df holdings equals df holdings dot ilog7 and going on. So if we look at df holdings now, we see that we removed those placeholder rows, and we can now create our header. Our header is now the 7th row here. And first we say df holdings equals, so df holdings dot rename, and we want to rename our columns. And what do we want to rename those with? We want to rename them as the first row. So we say df holdings dot ilog0. If you run that and look at df holdings now, we can see that our headers are now ticker, name, and so on. And now all we have to do is remove that first row. So we do the same thing we did before. So df holdings equals df holdings dot ilog, and this time we just remove the first one. And we see df holdings is now a nice data frame where we see Nvidia as our top holding with 7.8%, as well as Apple and Microsoft. Lastly, we now have to format the data so we can use it and clean it up a little bit. We can see, first of all, there's some futures and cash positions in here that we don't really care about. So we can say df holdings equals df holdings on asset class, and we just want to filter for everything that is an equity position. Next, we also want to clean up the ticker a little bit. There's from time to time something that we don't want to see, so we do df holdings equals df holdings on df holdings ticker, and we don't want it to be a double dash. I had some issues where there was some missing or wrong data, so we want to get rid of that as well. So if you look at df holdings now, we now see it got down to 503 rows because it removed some of the dummy rows that we don't really care about. The next step, we want to convert everything into numericals. You never know how it is stored, so I'm just copying this over. So we basically, for each column in our data frame, we see if it is a numeric, we transfer to a numeric, or if not, we just pass on it. And as well, now that we removed some rows, we want to make sure that our holdings, our weight is aligned. So we're going to say that our weight should be the weight divided by the sum of the weight. So if I run that and we look at df holdings again, let me put this down here. We now see that everything here, we had that 7.8% before, now it is transferred to a numeric. Lastly, we want to clean it up a little bit more, and we want to add a column where we say what index we're looking at. So df holdings on index should be S&P 500. And we will also want to add a date column. So let's do that here too. df holdings on date equals date.today. That just adds two convenience columns. So if you look at it, now we see we have an S&P 500 index and we have a date column in here. Next, we want to filter or resort our columns. So I'm just gonna copy that over so that our columns that we just created are at the beginning. Just easier to read if we start by date, index, and then have our information that we actually care about, such as ticker, the company name, the market value, the weight, the quantity, and so on. As a last step, we're gonna clean up the holdings columns a little bit by removing those weird placeholders, such as the percentage sign and the underscores, and now you can see it's in a nice database format where we have a date, index, ticker, just a market value, a weight column. Before we start storing all our data into our own local SQL database, let's start with a quick visualization first. So far we have downloaded the index holdings from the iShares website and stored them into a pandas data frame. So we can now easily plot it. This plot on the screen shows the distribution of the max 7 in our index. On the bottom we can see that Nvidia takes up roughly 8%, Apple around 7%, and you can see the weight for all other Mac 7 names plotted in purple here. On the left hand side, we can see that the box plot of the distribution of all names in market cap. You can see that we are heavily skewed towards the top with those big names, Nvidia, Apple, and Microsoft, and we have a big chunk of companies below the 10 billion valuation. On the right, we can see that roughly 34 to 35% currently of the whole S&P 500 is made up by our 7 Mac 7 companies. As a last step now, we want to store the data into our own SQL database so that it is reusable at every point in time. For example, if you run a backtesting strategy, you want to know as of January 1st, 2026, what is in my index so that we don't introduce any biases. To do so, we use the Python library SQLite 3. So let's start by importing the library. And similar to what we did before, let's start by creating our database link first. So we say our database location is we take the same download folder we used before, and we introduce a finance.sqlite database if I run that. And now from here on, it's fairly straightforward to use this. First, to use SQLite, we introduce a connection. So we just use the SQLite.connect, and we say database equals our database log that we just introduced. Perfect. Now that's already almost all. Now we have our df holdings that we introduced before, and we say df holdings.toSQL, and then we can just call the table name. The table name let's call it holdings, and we use the connection that we just created. And if it exists, we just create it, but if it exists, we just replace it for now. And we don't want to write our index here. And now if we run this database, it gives you that we wrote 503 rows. And you can see here now that we have a finance.sqlite database in our data folder, because that's where I specified it. Our download folder is that data folder. If I close that out, now lastly, let's close the connection so that it is not open anymore. And now we had stored our data into a database. Now if we want to use it, we can just connect back to it. SQLite 3.connect. We again say database equals database location. And now we can query it, for example. So we can say query equals. We can say something like select date ticker weight from holdings. Let's do where index equals S&P 500. In our database, we currently only have the S&P 500, but if you pull the Russell 1000 or other indices, you might want to filter it. And let's also say where and ticker in, let's only pull specific ones like AAPL, let's pull NVDA, we need single quotation marks here, and let's also pull Tesla. And that's already it. So we can now create a new df and say df is pd.read SQL query, and we can run query, and we still need the connection again that we created, and let's also close it again, just best standards. Now that already ran, you see, like very fast. And if we look at the F, we now see as of 2026, 131, Nvidia has 7.8%, and we also see the weights for Apple and Tesla. We've gone over a lot in this video. We started by building our own web scraper to scrape the holdings for the S&P 500, which you can easily extend to the Russell 1000 or Russell 3000 indices. We then took that data, formatted it in a nice and reusable way, and stored it into our own SQL database so that you can use it in your own backtesting strategies. We now only need to run this script on a daily basis to create a history of those holdings. In the next video, we're gonna show you how to do the same thing for company prices and company fundamentals so that we can build our own big financial database. Thank you for watching the video.